so let's move on to the discussion of the rate law. So when we're talking about the rate law of a reaction, we're talking about an actual mathematical expression which relates the rate of the reaction to the concentration of the reactants. All right. So if you have a hypothetical reaction such as the one that you see here on the screen, we can write a rate law for this reaction where the rate of the reaction is equal to K, a constant, times the concentration of A raised to some number X times the concentration of B raised to some number Y. All right. Now let's define some terms here. The X would be called the order of the reaction with respect to A, and the Y would be the order of the reaction with respect to B. The K would be the rate constant, which we talked about before. Now, there's a term called the total order, right? Which is basically the sum of the orders of the reactions of the different reactants, right? So in this case, the total order of this reaction would be X plus Y, all right? Basically, that's some introductory stuff concerning what we mean by the rate law, all right? For our purposes at this level, usually the X and Y values would be from 0, 1, or 2. You can have some other values as well, but that's a bit above our level here for general chemistry too. Okay, so just to illustrate how this applies to actual reactions, I want you to consider the reaction represented by the equation shown here. And below that, you see a data table. So somebody did this reaction using different concentrations of the reactants, and they determined the initial rates of these reactions, which are given over here. All right. So this is a type of table or the type of data that we can use to determine what the rate law of the reaction is. So we can write down the hypothetical rate law, which is rate is equal to K times the concentration of fluorine raised to the X times the concentration of ClO2 raised to the Y, all right? So our task is to find out what X and Y are, all right? The orders of the reaction with respect to F2 and ClO2, all right? Now you'll notice, if you look at the data very carefully, if you check out the first two rows here, 1 and 2, you'll notice, actually let me scratch that. If you check out the data comparison between 1 and 3, right, you'll notice that the concentration of fluorine is doubled while the concentration of ClO2 remains the same, right? And there's a corresponding change in the initial rate. So what that tells us is that the rate of the reaction here is only affected by the change in concentration of fluorine because, of course, there's no change in concentration of ClO2, so therefore there's no effect on the rate based on that. So therefore you'll notice that when this is doubled, when the concentration of fluorine is doubled, the initial rate is also doubled, all right? So what that means is that there's a linear relationship between the rate of the reaction and the fluorine. So in other words, the order of the reaction with respect to fluorine, X is equal to 1, all right? Now, in the case of ClO2, if you compare the first two set of data here, you'll notice that when the ClO2 concentration is quadrupled from 0.010 to 0.04, while the concentration of fluorine is constant, the initial rate is also quadrupled. So again, there's a linear relationship between the rate of reaction and the concentration of the ClO2. So what that tells us also is that the order of the reaction with respect to the ClO2 is 1, and therefore we can write down that the rate law is equal to K times the concentration of fluorine raised to the 1 times the concentration of ClO2 raised to the 1. So that's basically how you determine the rate law, all right? Later on, we're going to look at an example where we can also go ahead and determine the rate constant. In fact, let me show you how to do that now. It's quite easy. All you have to do is rearrange this equation here. Okay, so this equation here, you rearrange to solve for K. K is equal to rate divided by concentration of fluorine times concentration of ClO2. And then all you have to do is put the numbers in. So what you can do is choose any set of data. It doesn't matter which one. So for the sake of convenience, I'm just going to choose the first set of data here. So the initial rate for the first set would be 1.2 times 10 to the minus 3 divided by 0.10 times 0.010. This is M over S. This is M as far as the units are concerned. So let me do this on my calculator. So 1.2 times 10 to the minus 3 divided by 0.1 divided by 0.01. And according to my calculations, this works out to be equal to, okay, this works out to be equal to 1.2, and the units here would be, the m is going to cancel out here and here, so the unit is going to be m to the minus 1, s to the minus 1. So this would be the answer right here. All right. Okay. So that's how you determine the K value once you determine the orders of the reaction with respect to the different reactants. Okay, so a couple of things we need to say here about the rate laws. One, the rate laws are always determined experimentally. In other words, you cannot just look at a reaction or look at the balance equation and determine the rate law. You have to actually carry out an experiment where you determine the rates of the reactions at different concentrations of the different reactants, just as demonstrated in the table I showed you previously. Second thing you need to recognize, and this is very important because this is a common error that students tend to make when they're meeting this topic for the first time, and that is that the reaction order is always defined in terms of the reactants and not the products, all right? So we don't look at the products to determine the reaction order. We look at the reactants, and the reactants are the ones that will be involved or present in the rate law. Another important thing, which is another mistake that students tend to make, is to recognize that the order of reactants is not related to the coefficients in the balanced equation, right? So you cannot just look at the balanced equation, look at the coefficients, and just say that's the order of the reaction with respect to that particular reactant, all right? So going back to the previous example that we had here, you'll notice that the coefficient for the ClO2 is 2, right? But the order of the reaction with respect to ClO2 is 1, right? So there's no necessary correlation between the order of the reaction and the coefficient of the substance involved in the reaction. Now, there are some instances where coincidentally they're the same, right? So, for example, in the case of fluorine, in this reaction, let me go back to my pointer here. In the case of fluorine, it's 1 here for the coefficient, and the order is 1 here, but that is purely coincidental, all right? So that's a very important point you need to recognize. You cannot just look at the coefficient of the reaction for a particular reactant and assume that that would be the order of that reactant in the reaction, all right? Okay, so I'm going to stop here because I want to spend some time looking at this example, showing you how to work out this type of problem where you're asked to determine the rate law and the rate constant. Okay, on to next time.